everyone. In this video we'll start discussing fractions in more detail, focusing on how they add and subtract. First, let's review some terminology. In general, a fraction is simply made of some number or expression divided by another number or expression. This bar in the middle is what represents division. The expression on top is referred to as the numerator, while the expression on the bottom is referred to as the denominator. This fraction, which represents 5 divided by 7, can be referred to as 5 over 7 or 5/7. Fractions can be rewritten without changing their values as long as we operate on the numerator and denominator with the same multiplication or division. For example, if we take this 5 over 7 and multiply both the numerator and the denominator by 2, on top we get 5 times 2, which is 10, while the bottom is 7 times 2, which is 14. Altering a fraction like this is the same as multiplying by 1, but writing it in a certain way to get what you want. Because we've just multiplied by 1, you can plug both of these expressions into a calculator, the 5 over 7 and the 10 over 14, and see that you get the same numerical result. We can go about this same process with division, and in fact this is how we simplify fractions, which is often requested in math problems. Take, for example, 10 over 25. To simplify this, we want to check to see if there's a number that fits evenly into both the numerator and the denominator evenly. Here we see that 5 can fit into both the 10 and the 25, so we're going to divide both the top and the bottom by that common factor. Dividing 10 by 5, 5 fits into 10 twice. Meanwhile, on the bottom, 25 divided by 5, 5 fits into 25 5 times. We now have 2 over 5, and there are no other numbers that fit evenly into both 2 and 5, aside from 1, so this fraction is in its most simplified form. Let's now move on to adding or subtracting fractions. In order to add or subtract, the fractions must have the same denominator. This is referred to as a common denominator. If we had some number a over another number c being added to another number b over that same c, the way we add these two fractions, since they already have a common denominator, is we simply take the numerators, a and b in this case, and do the addition operation and get a plus b is now the numerator, divided by that same denominator c, which stays the same. Meanwhile, for subtraction, we get something very similar, a over c minus b over c. We already have a common denominator c, so our result is just going to be a minus b all over that common denominator c. For an example, consider 4 over 7 plus 3 over 7. Since we already have a common denominator of 7, that will stay the same on our denominator, while the numerator becomes the addition of the two numerators, 4 plus 3. Doing the addition gives 7 over 7. 7 divided by 7 is just going to give 1. Now let's consider subtracting these numbers. Again, we already have a common denominator, so we'll just subtract across the numerators, keep that same denominator 7. Doing the subtraction, 4 minus 3 gives 1, still divided by 7. So we get 1 over 7, and there's nothing we can do to simplify this, so we're done. The difficulty in adding or subtracting fractions comes from when they don't already share a denominator, and we have to rewrite them to get a common denominator. To start, take 1/2 plus 3 over 8. We want to use multiplication to rewrite these fractions with the same denominator. We have to look at the denominators 2 and 8 and think about what we could do to make them match. Realizing that we can turn this 2 into an 8 by multiplying by 4 will make this easy. We just have to make sure whatever operation we do to the bottom, we also do to the top, so we don't change the fraction's value. Multiplying the top and bottom of the 1/2 by 4 will give 1 times 4 on top, which will be 4, over 2 times 4 on the bottom, 2 times 4 is 8, still being added to 3 over 8. Now that they have the same denominator, we can easily add these fractions to get 4 plus 3 on top, still the 8 on the bottom. Doing the addition gives 7 over 8. There's nothing we can do to simplify this, so we're done. A guaranteed way to get a common denominator between two fractions is to multiply each by the other's denominator. For example, we could take this 2/3 and multiply the top and bottom by the 7 of the denominator we're trying to subtract, and also multiply the 3 on the first denominator into the second fraction. Doing the multiplication on the first fraction, we get 2 times 7, which is 14 on top, 3 times 7, which is 21 on the bottom. Then we'll be subtracting 1 times 3 is 3 on the top, and 7 times 3 is 21 on the bottom. So you see, doing this multiplication, we've ended up with the same denominators. Doing the subtraction will give 14 minus 3 on the top, and still the 21 on the bottom, which is going to give 11 over 21, which is already simplified, so we're done. While this method guarantees us common denominators, it's not always the best option, as in many cases we don't simply just want any common denominator, but what is called the least common denominator, the smallest number or expression that each denominator will fit into. For one last example, consider 8 over 15 plus 3 over 10. While we could multiply the 15 and the 10 together to get denominators of 150, we notice that both 15 and 10 can fit into 30. To get to 30 from the 15, it must be multiplied by 2, and we have to do the same to the top. Meanwhile, in the second fraction, to get to 30 from 10, it has to be multiplied by 3, which means we also have to multiply the top by 3. Doing all the multiplication will give us 16 over 30, plus 3 times 3 is 9 over 30. And adding these together, we just get 16 plus 9 on top, 30 on the bottom, which is going to give 25 over 30. Before we can say we're done, we notice that both the 25 and the 30 can be divided by 5 evenly. So simplifying by doing this division, 25 over 5 will be 5 on top, 30 over 5 gives 6 on the bottom, and there's nothing else we can fit into both these numbers, so this is our simplified answer. Utilizing the least common denominator becomes more important when we end up with rational expressions with a variable in the denominator, and we want to add them like this. While this is beyond the scope of today's video, you can go check out another video on this subject on our channel. Until next time.